Question 24. A trolley moves down a slope with constant acceleration. The mass of the trolley is doubled and the trolley moves down the same slope again. Air resistance and friction are negligible. Which is correct? Say which is correct. I'm just going to do a bit of explanation here. We have a slope at an angle theta and there is a force in that direction. I can do this. So start, finish. The vertical force will be Fv, and we can say Fv is mg sine theta. Fh, that would be mg cos theta. And so we can say that sine of an angle theta will be the sine of this angle would be Fv over the hypotenuse here, which is mg, because that hypotenuse will be the weight that you're pulling along. And so we can say Fv is mg sine theta. For the horizontal, we can say cos theta will be, cos is adjacent over hypotenuse, and so that would be Fh is the adjacent divided by the hypotenuse, which is mg. Fh equals mg cos theta. So if we just pick one of them, we can use that one or this one to solve this problem. Let's use that one. So we have for F1, that is before you double the mass, and that will be equal to ma, because it is the acceleration that is dragging it along, but the acceleration is constant. So we look at F2, that would be 2mg sine theta, that would be 2ma. Now, if we do the ratio of these two regarding the forces, we can see that F2 over F1 will be equal to that over that. So that would be 2mg sine theta over mg sine theta. And those two will cancel out, and that will be equal to 2F2 would be 2F1. If we double the mass in second one, we double the force. What about in terms of acceleration? The F1 is equal to ma, and that is equal to mg sine theta. And therefore, m cancels m. You can see that would be equal to g sine theta, and that equals to a. What about for F2? 2ma will be equal to 2mg sine theta. Again, if we cancel the 2 here and 2 there, you can see that a is equal to g sine theta. So a is dependent on the angle theta. This is the diagram, and we're using F1 and F2, and those are the relationship. For the force, the ratio of the two will give us F2 equals to F1. And for acceleration, we do mg sine theta equals ma, and that gives us a equals to g sine theta. For when we double the mass, 2mg sine theta equals to 2ma. Again, when we cancel out the common factor, we get a equals to g sine theta. So if you're looking at a here, the accelerating force, which means that, is unchanged. But that's not true, right? Because F2 now is doubled F1. So that's changed. So that's not true. The accelerating force is half. Well, it's not half, is it? It's doubled. The acceleration is unchanged. Well, that's true, because a is g sine theta in the first case, a is g sine theta in the second case. So that's unchanged. The acceleration is half. That's not true, right? It's the same. So the answer will be C.